In this video, I will talk about the coefficient of the volume expansion. Whenever we have a material like a rod or a sphere, a disc, and when you hit it, it expands. Even a liquid, when you hit a liquid, it expands. So how do you calculate or how do you find out what is the change in the volume of the liquid or the sphere or a cylinder? And we're going to do it in this video. So let's say you have a box, a cubical box. The length, width, and the height is given. And after hitting this one, the length changes, the width changes, the height changes. And now we have a new volume. And that volume we call the final volume. VF stands for the final volume. And this final volume is equal to the initial volume plus there is a change in the volume, the delta V. The volume expansion coefficient is defined as a change in volume per unit original volume per unit change in the temperature. Okay, so this is the way it is defined. The change in volume divided by the original volume divided by the delta T is called the volume expansion coefficient, and it is denoted by the term beta. Beta is called the volume expansion coefficient. And remember, delta V is the change in volume, which is given by the final volume minus initial volume. Delta T is the change in temperature, which is TF minus Ti. And if you look at the unit, the delta V and the V has the same unit. So the unit of beta will be 1 over degree Celsius or degree Kelvin, whatever unit you prefer. Either 1 over degree Celsius or 1 over Kelvin. So here the unit is 1 over degree Celsius. And from this equation, you can also calculate the change in volume here too. The change in the volume would be equal to beta, the original volume, times the delta T. This is the formula here to calculate the change in the volume, and you can simply calculate from this equation. And here I have not done mathematically, but I would like to point you one note to you that this volume expansion coefficient is approximately, not exactly, is equal to 3 times the change or the 3 times the linear expansion coefficient alpha. Okay, so what does that mean? That means when you increase the temperature, the length expands, the width expands, the height expands. So if you know the linear expansion coefficient of a certain material, then you can simply multiply by 3 to get the volume expansion coefficient. Okay, so this formula, how do I get this one? I have calculated this one in one video, and I will post the link in the description section below. If you look at the list for the material of the linear coefficient and volume coefficient, it is listed here. So for aluminum, we generally use the average linear coefficient, and all the values are given here. And this is for the liquid and gases. We measure with the volume expansion coefficient, and it is listed here. Okay, for a solid material, we generally use the average linear coefficient. And for the liquid and gases, we use the volume expansion coefficient. Okay, so this is it for the coefficient of volume expansion. If you have any questions, write down your questions in the comment section below. And do not forget to like, share, and subscribe the channel. Thank you very much.